Good morning, one and all. I hope everyone is doing good. Now, let me begin the session. That is session number 5 associated with this module 3, that is time response of feedback control systems. Now, so far with this module 3, we have covered 4 sessions. With the 4 sessions, we understood the concepts, basic concepts of time response of feedback control systems. Now, what are all the basic concepts we understood? We understood what is transient response, what is steady state response, then the different types of inputs applicable for an feedback control systems. Later, we had the analysis of first order system and second order system for unit step input. Is it okay? Apart from understanding the analysis for unit step input, we also understood the expression for C of t, output response for first order system, and for second order system for underdamped case, if I remember, which is given by C of t is equal to 1 minus e power minus I omega n t divided by root of 1 minus I square into sine of omega dt plus phi, where phi is equal to tan inverse of root of 1 minus I square divided by xi. Is it okay? Apart from understanding the expression derivation, we also concentrated with the derivation part for delay time, rise time, peak time, maximum overshoot, and settling time for second order system under damped case where xi less than 1. Is it okay? And those were all the theory concepts what I covered with this module 3. Is it okay? And in the previous class, that is session 4, we had the discussion associated with the problems, and those problems were concerned with first order system. First order system response. Is it okay for unit step input and also for unit ramp cases problems we understood. In the one set of problems where certain open loop transfer function is given, input R of t is given, and he has asked us to evaluate overall transfer function, closed loop transfer function, and output response C of t. That was the one set of problem. With the other set of problem, we concentrated as such where C of t it was given, R of t it was given. Later we evaluated the transfer function. Apart from evaluating the transfer function, open loop transfer function and closed loop transfer function, we also evaluated the output for ramp input. That was the other kind of problem what we come across. And we had one more set of problem for that first order system where the value of C of t it was given for certain time t, and generic transfer function was given in terms of certain constant. Later we evaluated the constant value from the given C of t and t. Is that okay? And these were all the problems what we discussed in previous session, that is session 4. Now I'll extend my discussion associated with the problems on second order system under this session 5. Now this session 5 is associated with the learning objective is to apply the concept of second order unit step response analysis to a given problem. Then how about the flow of content? Like we need to have problems on second order system. Before I proceed with the second order system,
ಆ ವಸ್ತುಗಳನ್ನು ಹಾಗೂ ಅದರಲ್ಲಿ ಬರೆದಿರುವ ಮಾಹಿತಿಯನ್ನು ಗಮನಿಸಿ. ಮತ್ತೊಂದು ಬಜಾರ್ ಆದಾಗ
Tejaswini P. Now guys, we need to have problems on second order system. Now before I proceed with the problems on second order system, first try to recall the transfer function associated with the second order system, which is given by C of s by R of s is equal to omega n square divided by s square plus 2 xi omega ns plus omega n square. That is the standard function associated with the second order system. Is it okay? Now I shall concentrate with the problem, that is problem 4. Now what is the statement associated with this problem 4? Now what is the problem 4? It says for a unity feedback system having open loop transfer function g of s 1 divided by s into s plus 1. Determine damping ratio. We need to determine damping ratio xi, undamped natural frequency omega n, then peak time Tp we need to determine, followed by maximum overshoot MP. These are all the parameters to be determined by considering as unit step input. What is the value of R of t? R of t is equal to U of t. That means this is an second order system for unit step input. Is it okay? Now, as per given, what are all the parameters he has specified? Open loop transfer function is given. G of s is equal to 1 divided by s into s plus 1. And h of s is equal to 1. What is h of s is equal to 1? That is unity feedback control system. Now, let me evaluate the closed loop transfer function. How about the expression for closed loop transfer function? C of s by R of s is equal to G divided by 1 plus G into H, or G of s into H of s. Now, what is G of s? 1 divided by s into s plus 1 whole divided by 1 plus 1 divided by s into s plus 1 into 1. Why? Because h of s is 1. Later, if I try to take the LCM and if I try to simplify, this I may cancel. Now this it goes to numerator. Now what do we have? S into s plus 1 plus 1. Is it okay? Finally, what does it results? Finally, it results with the value C of s by R of s is equal to 1 in the numerator divided by s square plus s plus 1. S square plus s plus 1. Is it okay? Now this is the closed loop transfer function. But what we need to determine? We need to determine the value of xi, omega n, Tp and Mp. Thereby next step what I do? I shall compare this obtained transfer function with the standard transfer function. Now what is the standard transfer function for second order system? Omega n square divided by s square plus 2 xi omega ns plus omega n square. I shall compare this two. Next step, if I try to compare this two, now comparing with the standard transfer function. Now after comparison, this is 1 divided by s square plus s plus 1. After comparison, what is the value of omega n square? Omega n square is 1. What is omega n? Root of 1, that is 1 radians per second. Next, in the denominator, 2 xi omega ns. Now this is s. Is it okay? This coefficient is 1. Thereby 2 xi omega n is equal to 1, or what is xi? Xi is equal to 1 by 2 omega n. Omega n is 1. Thereby this is 1 divided by 2 into 1, which is 0.5. Now what is the value of xi? Xi 0.5, which is less than 1, as it is underdamped case. ಗೊತ್ತಾಯ್ತಲ್ಲ, ಈ ರೀತಿ ನೀವು ಇದನ್ನ ಅನಲೈಸ್ ಮಾಡಬೇಕು. This is underdamped case. Is it okay? Next, what we need to determine? We need to determine the value of Tp. What is Tp? Peak time. Peak time is given by this relation, pi divided by omega d. You need to recall that relation what we discussed in session 3 derivations. Is it okay? For second order system, pi divided by omega d. Omega n is undamped natural frequency, wherein omega d is damped natural frequency, which is given by this relation, omega n into root of 1 minus xi square. Is it okay? Now pi as it is, omega d is omega n into root of 1 minus xi square, 1 as it is, omega n root of 1 minus xi square, 0.5 whole square. Is it okay? Like after simplification, this Tp, it results with a value pi divided by root of 1 minus 0.25, that is root of 0.75. After simplification, it results with the value 3.627 seconds. Now you do one thing, you please try to take your calci and you just cross check. Wherein your calculator, it need to be in radians mode. Isn't verify ಮಾಡ್ಕೊಳ್ಳಿ ಬೇಗ. Pi divided by root of 0.75, it need to result with a value 3.627 seconds. Please check out, guys. Your calculator, it need to be in radians mode. Now are you getting the result as 3.627?
Yes, sir.
Okay. How about others? ತೇಜಸ್ವಿನಿ BN, ತೇಜಸ್ವಿನಿ P. ಇಬ್ರು ಇದ್ದೀರಾ ಕ್ಲಾಸಲ್ಲಿ? ತೇಜಸ್ವಿನಿ BN and ತೇಜಸ್ವಿನಿ P. I repeat, Tejaswini BN and Tejaswini P. Tejaswini BN and Tejaswini P. Tejaswini BN. Now guys, next if I proceed with maximum overshoot MP, now how do we determine the value of MP, maximum overshoot? E power minus xi pi divided by root of 1 minus xi square. Now how about the value of xi? Xi is 0.5, that is e to the power of minus 0.5 pi root of 1 minus 0.25. You please try to take your calculator and you just cross check. E to the power of minus 0.5 pi divided by root of 1 minus 0.5. First try to simplify this. 0.5 pi divided by root of 0.75. What the value you used to get. Later you please try to calculate e to the power of minus that value. Then it need to result with this 0.163. You please try to cross check this.
Yes, sir.
Yes, sir. 0.1630.
0.1630. This is not in percentage. If you want percentage into 100, then you will get the percentage as 16.3%. Is it clear now, guys? This is how you need to find the required parameters from the given input set of values as per the problem. Is it okay? Now this is one simple problem associated with the second order system. Now let me proceed the discussion with the next problem, that is problem number 5. Next, what is the statement of this problem number 5? It says a position control system has open loop transfer function g of s 4 divided by s plus 2 and h of s is 1 by s. It is not open like unity feedback control system. Why? Because h of s is 1 by s. Is it okay? G of s is given. Now how about the value of g of s? 4 divided by s plus 2 and h of s is given. How about h of s? H of s is equal to 1 by s. Now what we supposed to find? Damping ratio xi, damping factor sigma, then peak time Tp we need to find, maximum overshoot. Is it okay? For maximum overshoot, consider as unit step input. Is it okay? Since damping ratio, damping factor has been asked, this is associated with the second order system. Is it okay? Now you can evaluate this in two ways. First, you can find C of S by R of S, what we evaluated in the previous problem. Adu one ರೀತಿ. ಅಥವಾ directly you can go for the transfer function. Now how about the transfer function? 1 plus G of S into H of S. You can use that, or overall transfer function G of S divided by 1 plus G of S into H of S. Instead of this two, you can use any one relation. Is it okay? Now if I use this transfer function, characteristic equation relation, 1 plus G of S into H of S is equal to 0. 1 plus G of S is 4 into S plus 2. H of S is 1 by S. After simplification, S square plus 2S plus 4 is equal to 0. I may compare this with the standard relation. S square plus 2 xi omega ns plus omega n square. Now what is omega n square? Omega n square is equal to 4, or omega n is 2 radians per second. Next, 2 xi omega n is equal to 2. Then what is xi? Xi is equal to 0.5. Since xi is equal to 0.5, once again it is under damped case. Next, I shall find this damping factor sigma, which is nothing but xi into omega n. Xi is available, omega n is available. You just multiply this. 0.5 into 2 is 1 radians per second. Is it okay? Right. Next, TP, peak time. How about the expression for peak time? Pi divided by omega d, that is pi divided by omega n into root of 1 minus I square, pi divided by 2 into root of 1 minus 0.5 whole square, which is 1.813 seconds. Similarly, you need to use the values for this maximum overshoot. Maximum overshoot is e power minus I pi divided by root of 1 minus I square, and you just cross check these values by using your calculator. Kiran Kumar, yes. Kiran Kumar, yes.
Yes, sir.
ಕ್ಯಾಲ್ಸಿಯಲ್
Hello.
ವೆರಿಫೈ ಮಾಡ್ರಿ, ಅದನ್ನ ಆನ್ಸರ್ ಏನ್ ಬರುತ್ತೆ ನೋಡಿ, ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡಿ. Tejaswini BM, Tejaswini 19:38. Since I have been calling from long time, you are not replying. Tejaswini BM 19:38. Netravati 20:416.
Yes, sir.
Sir, 0.1 shoot.
Swati 19:37.
Yes, sir.
ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀರೇನ್ರಿ
ಸರ್ ಇದ್ದೀನಿ ಸರ್.
ಅಥವಾ ಬೇರೆ ಕಡೆ ಎಲ್ಲಾದ್ರೂ ಲಾಗಿನ್ ಆಗ್ಬಿಟ್ಟು ಹಾಗೆ ಮ್ಯೂಟ್ ಮಾಡಿ ಹೋಗಿದ್ದೀರಾ? ಇಲ್ಲಿ ನೋಡಿ, ಯಾರೋ ನಿಮ್ಮ ಕ್ಲಾಸ್ಮೇಟ್ ಹೋಗಿದ್ದಾರೆ. ತೇಜಸ್ವಿನಿ BN 19:38. Sindhu R 19:34. Sindhu R Pavitra T, 20 EC 418.
Yes, sir.
Rekha Sri, Rekha Sri, Tejaswini, Sindhu, no reply at all. Divyashree, 20 EC 405.
Sir.
Apu DK, 19 EC 4. This is one more candidate. Then Madhura, 19 EC 22.
Yes, sir.
ಏನಪ್ಪ ಅಪ್ಪು ಡಿ ಕೆ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೆ ಇಲ್ಲಿ ಇಷ್ಟೋ ತನಕ? Okay, fine guys. Like some students they have simply logged into the class and they are physically not at all available. Even if I call their names, they are not at all replying. Okay, fine. This is your fate. Even I can't help out with such kinds of things. Then we had the discussion concerned with problem 5. Next, I will move on to problem 6. Now with this problem 6, how about the statement? A unity feedback system is characterized by an open loop transfer function. G of S is equal to K divided by S into S plus 10. Is it okay? Now certain G of S is given. Open loop transfer function is given. K divided by S into S plus 10. Now what we're supposed to find? We need to find the value of K constant so that the system will have the damping ratio of Xi. Xi as 0.5. Now this is quite different problem. So far what the problems we concentrated were G of S and H of S is what it was given, and we were finding Xi, omega n, omega d. Later we finding TP, MP and so on. But in the current problem, open loop transfer function has got some constant K. We need to find the value of K, but Xi value has been given. Is it okay? Now for this Xi 0.5, we need to find the value of K. Then we need to find MP, TP and TS. That is peak time, settling time for a unit step input. Is it okay? Now how do I determine this? Let me recall the characteristic equation. How about the characteristic equation? 1 plus G of S into H of S. Is it okay? G of S is available. K divided by S into S plus 10. H of S is 1. Is it fine? Later, like if I try to simplify with the overall transfer function, this is the overall transfer function. K divided by S square plus 10S plus K. Then after comparing this with the standard transfer function for second order system, omega n square divided by S square plus 2 xi omega ns plus omega n square. Later we may able to have the parameters as omega n square is equal to K. 2 xi omega n is equal to 10. Is it okay? Right? Later you please try to understand. Next what I will do, strictly speaking, if I try to find the value of xi is equal to 10 divided by 2 omega n. Omega n is nothing but root of K. Is it okay? Let me simplify this. Xi is equal to 10 divided by 2 into root of K. Next step, omega n is equal to root of K, but xi is equal to 10 divided by 2 into root of K. Next, I will substitute the value of xi over here. Xi is 0.5. Is it okay? Now I'll cross multiply. What I do, I'll try to take this root k over here and 0.5 to denominator. Then this is root k is equal to 10 divided by 1. Is it okay? Next, to avoid this root, I'll square on both sides. Square, square. Now what do I get? This square and square root, it gets cancels. K is equal to 100. 10 square is 100. Thereby, what is the value of k? K is equal to 100. Now for this k is equal to 100, let me evaluate the value of omega n. What is omega n? Omega n is equal to root of k, or k is equal to omega n square. Thereby, strictly speaking, if I try to evaluate the value of omega n, is it okay? Root of 100 is nothing but 10. Is it fine? Xi is available, omega n is available. Later, I shall find the value of omega d. What is omega d? Omega n into root of 1 minus xi square. That is 10 into root of 1 minus 0.5 whole square, which is 8.66 radians per second. Is it okay? The same relation what we need to use. Next, I shall go for TS. TS is equal to settling time for two cases of tolerance, 5% and 2%. For 2%, it is 4 divided by xi omega n. 4 divided by xi is 0.5 and omega n is 10, which is 0.8 seconds. Then TP is equal to pi divided by omega d, which is pi divided by 8.66. Omega d just now we have calculated from this relation. Is it okay? You please try to evaluate this value. Then what is MP? E power minus I pi divided by root of 1 minus I square, and you just cross check, it results with a value of 0.163 or 16.3%. Is it okay? This is the other problem where for the given xi we have evaluated k, and from that k we evaluated MP, TS and TP and so on. Is it okay? Next I will move on to the next problem, that is problem 7. This is quite different when compared with the other problems what we had taken so far. Now for a unity feedback control system, G of S is given. Now what we supposed to write? We need to write the output response for unit step input. And we need to find the response at t is equal to 0.1 second, maximum value of the response and the time at which it occurs, that is unsettling time. The time at which it occurs is TP. Is it okay? Only G of S is given. Now for this we need to write the response, that is C of t. Since G of S is given and it is unity feedback, let me evaluate this. Now if I try to evaluate the overall transfer function, it results with a value 64 divided by S square plus 9.6S plus 64. Now what is the generic expression we have? This is the generic expression for output of second order system. 1 minus e power minus I omega nt divided by root of 1 minus I square into sine of omega dt plus 5. ನೋಡಿ ಈಗ ನಮಗೆ xi ಬೇಕು, omega n ಬೇಕು, omega d ಬೇಕು ಮತ್ತೆ phi ಬೇಕು, right? Now let me recall or let me compare this with the standard equation, that is s square plus 2 xi omega ns plus omega n square. After comparison, omega n is 8 radians per second, 2 xi omega ns is 9.6 or xi is equal to 0.6, which is less than 1 and it is under damped case. Omega d, omega n into root of 1 minus xi square, which is 6.4 radians per second. Then phi, how do I find phi? Tan inverse of root of 1 minus xi square divided by xi. This is in degrees and this is in radians. Better to evaluate in radians. Okay, ಇದೆಲ್ಲ values evaluate ಮಾಡ್ಕೊಂಡ ಮೇಲೆ you need to substitute with this 1 minus e power minus xi omega nt divided by root of 1 minus xi square into sine of omega dt plus 5. Now C of t is equal to 1 minus 1.25. This value has been resulted after evaluating this. 1.25 e power minus 4.80 into sine of 6.40 plus 0.9272. After substituting the values, and please try to understand, calculator it need to be in radians mode. Then what we need to find? We need to find the response value at t is equal to 0.1 second. Now let me substitute t is equal to 0.1 second to find the c of t. Next step, if I try to substitute t is equal to 0.1, ನೋಡಿ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅಲ್ಲಿ ಇಲ್ಲಿ t ಜಾಗದಲ್ಲಿ 0.1 ಹಾಕೋಬೇಕಾಗ್ತದೆ. Substitute ಮಾಡಿದಾಗ and this results with this value. This is 0.2265. Then Tp pi divided by omega d, which is 0.4908 seconds. Then at output at t is equal to Tp. T is equal to Tp in the sense Tp has been resulted with 0.4908. Illi 0.1 idu 0.4908 substitute madadre we get the value of c of t as 1.0948. And settling time for 2% tolerance, this is 4 divided by xi omega n, which is 4 divided by 4.8. This is 0.833 seconds. Is it okay? This is how you need to evaluate the parameters for the given things.